Good morning, students. Our new topic in the topic of differential equations in the subject of pure mathematics 3 in the class of A levels is formulation of the differential equations. So the differential equations can be formulated from rate of change using a constant of proportionality if necessary. So here we are going to solve some questions that will make your concepts more clear. So look now, write the differential equation for the following statement using k as the constant of proportionality. So we are starting from the second part. The length of the metal x increases at a rate proportional to its length. So look now, x increases at the rate. So it means, so look now, here is the solution. So dx over dt will be proportional to x. So when we will change this proportionality sign into equality, we will put a constant k of proportionality with the right hand side value. So dx over dt will be equal to kx. So rate is positive. So look now, third part now. So here is the third part. When heated, the length L of a rod increases at the rate. So L increases at the rate. So it means dl over dt. Okay, proportional to the square of the length. So will be proportional to L square. So look now, here is the solution of the third part. So dl over dt will be proportional to L square. So convert this proportionality sign into equality and put a constant k to the right side value. So dl over dt will be equal to k L square. Rate is positive because increasing. So look, here is another part, that is fourth part. This is the number n of the bacteria increases at the rate. So it means dn over dt, which is inversely proportional to its value. So proportionality sign and 1 over n will be placed on the right side. So look now, fourth part. So dn over dt proportional to 1 over n. So now this proportionality sign will be converted into equality sign and put a constant k on the right hand side value. So dn over dt will be equal to k over n. So rate is positive. So look now, again next part, that is fifth part. So the fifth part is the temperature T of the hot object decreases. Okay, here is decreasing. So it means this will be negative rate. So first look, T of the hot object decreases. So it means dt over dt. Okay, proportional to its value at any time. So will be equal to t, but because it is decreasing, so minus t will be on the right hand side. So look now, here is the answer. So dt over dt will be proportional to minus t because this was decreasing. Same method will be adopted. So proportionality sign will be converted into equality sign and put a constant k to the right hand side value. So rate is negative. Okay, next, see, this is the sixth part. The rate of cooling of an object is proportional to the difference. So look now, the rate of cooling of an object is proportional to the difference between the temperature of the body theta and temperature of the surrounding theta s. So rate of the cooling of an object. So because object's temperature is theta, so d theta over dt will be proportional to the difference between the temperature of the body and the surrounding. So will be proportional to theta s minus theta. So look now the solution. So here is the solution. D theta over dt is proportional to theta s minus theta. From here, proportionality sign will be converted into equality, and a constant of the proportionality will be put to the right hand side value. So this is the thing. Okay, next, the last part is at any time t days, the birth rate of the fish is equal to 100 of the number 100th of the number n of fish present. So it means dn over dt will be proportional to n by 100 because 100th is the given of the fish present. So look now, at any time the birth rate is equal to the birth rate of fish present. Okay, fish present. So present mean something will be subtracted. So look now, fish are taken from the lake at the rate of r per day. So when this is taken, so the left thing will be n minus r. So n by 100 minus r will be left. So look now, this is the solution. So dn over dt is equal to n over r minus 100. So the same thing will be solved now. Put a constant k to the right hand side value, so this thing will be obtained. Here is a question that will make your concepts more clear, and you will understand how questions come from this topic in the topic of the differential equation in A levels. So the question is, a disease is spreading through a population. Let P be the proportion infected at time t. So it means the infected persons, if there are P, so the not infected persons will be 1 minus P. Okay. The next thing that is given, the rate of the increase of the P. So rate of increase of P stands for dP over dt is proportional to product of the proportion of the people infected and the proportion not infected. So dP over dt will be sign of proportion will be placed. On the right hand side will be P into 1 minus P. So look now, dP over dt is proportional to P into 1 minus P. So now you will convert this proportionality sign into equality and put a constant k on the right hand side value. So look at the question again. So the first part was show that P satisfies the differential equation. So we have proved this thing. So first part is done. So look here, this is the thing which is proved. Okay, the second part is show that the solution of this differential equation can be written in the form. So now we will solve this differential equation which is given in the first part, and it is given that it will be reduces to this equation. So we have to prove it. So look now, 1 over P into P 1 minus P into dP will be equal to k dt. So first you will solve it partially. So A over P plus 1 over A minus P. So you will solve it like you have understand this method earlier. So from that process you will get the values of A 1 and B is also 1. So actually that is solved partially. Okay, from here you will integrate both sides. First you will take the integrate both sides. So look now, minus P's differential will be minus 1. So you will multiply and divide the numerator and denominator by minus 1. So it will be minus natural log of 1 minus P. And integral of this thing will be natural log of P is equal to kt plus c. At this step you will let this c equal to natural log of a. So look now, minus natural log of 1 minus p plus natural log of p is equal to kt plus natural log of a. Now you will take this natural log of a to the left hand side. So on the right hand side kt will be left. So from here you can see these two values are minus, so you will take minus common here. So this value P will be put in numerator, and these two values 1 minus P and A will be put in denominator, and natural log will be there. So natural log of P over A into 1 minus P. So I'm telling you the method. First you will take minus common here. and inside the bracket then these two values will be plus, so the plus means these values will be multiplied, so this will be multiplied in the denominator, but because of these values will be minus, so minus was taken actually, so that's why these values will come into the denominator and this p is in the numerator. So actually author is solving it very directly. kt is left on the right hand side, so now finish this natural log, so right hand side value will go into the e raised to the power, so on the left hand side p over a into 1 minus p is left, and right hand side is e raised to power kt. So actually we want to make p the subject, that was the requirement, so from here denominator will go to the right hand side, so a e kt minus p a kt, so p's values will be combined now, so take this value to the left hand side, so it will become plus. From here take p the common, so inside the bracket this will be the factor now, and then send this factor to the denominator, so this will be the thing which is proved. Okay, now up to here we have proved things, so moving further, initially the proportion infected is 2%, so initially stands for the time when time is 0. The proportion infected is 2%, so proportion infected was p, so 2% means 0.02 and half of the population is infected after 2 years, and after some years, after 2 years, the half of the population stands for 0.5, so p is equal to 0.5. So these are two sets of the values, one is t0 when p is equal to 0.02 and second is t is equal to 2 and p is equal to 0.5. So we will put these two sets of the values one by one in this thing. So look now, so here is the third part, you can see. So look now, when t is equal to 0, p is equal to 0.02. So this is the first set which is going to be put into the equation. So look now, we have put 0.02 in place of the p, and t is equal to 0 in the equation. So this factor and this factor will become 1, because in the power if there is 0 that become 1. So 1 over 1 plus 1. So 0.02. So e raised to power 0 is 1, e raised to power 0 is 1. So 1 into a and 1 into a. So a over 1 plus a. On the right hand side, cross multiply the values from where you can find the value of the a, that is 149, 1 by 49. Okay, put this value of 1 by 49 into the equation. So after putting the value of the a that you have find out into the equation, this will become the shape of the equation. Okay, now the second set of the values, that is p is equal to 2 and p is equal to 0.5. So in this statement it was given that after 2 years half of the population was infected, so p is equal to 0.5 and t is equal to 2 will be put into this equation now. So after putting into the equation you will get the equation of this form. Okay, from here you will combine the values that are involving e raised to power 2k, and from there 2k will be find out, so k will be find out like this. So this is the value of the k. Okay, the next part, that is fourth part, is, so look here, this is the fourth part in front of you now. What happens to the population when t becomes very large? So look at the answer now. So here is the answer. So this was the equation that was obtained. So when t becomes very large, that is t is equal to infinity. So first you will divide numerator and denominator by e raised to power 1.95495t. So in numerator it will become 1. Here will become 49 e raised to power minus 1.95t, and this factor will become 1. So when t becomes very large, so this factor will be 0. So 1 over 1 will be there. So p is equal to 1. The proportion infected is 1, meaning the whole population will be infected when time becomes very large. So after a lot of years, the full population will be infected. Okay, here is another question. The statement of the question is the rate of the increase of the variable x. So rate of the increase of the variable x stands for dx over dt is proportional to 100 minus x whole square. So look now, dx over dt is proportional to 100 minus x whole square. So the next statement is when t is equal to 0, x is equal to 0 and dx over dt is equal to 10, show that x satisfies the differential equation 1000 dx over dt is equal to 100 minus x whole square. So from first step, you will solve the equation now. So you will start from the first step. So first, proportionality sign will be converted into equality sign and put a constant k with the right hand side value. So this will be the step. So the next step will be, because it is given that in the question, so you can see it is given that in the question that t is equal to 0 when x is equal to 0, when dx over dt is equal to 10. So first we will put these values, dx over dt is equal to 10. So look into the question now. So dx over dt is equal to 10. So now t is 10 is equal to k into 100 minus x is 0. So 0 is put. So from here you will find the value of the k. So here is k. Okay, now put this value of k into the equation. So it will become 1 by 1000 is into 100 minus x whole square is equal to dx over dt. From here 1000 will come to the left hand side. So this is the thing which is proved in the first part. So you can see first part is done. Second part is show that the solution of this differential equation can be written in the form. So now it is requirement that solve this equation, and this should be the answer of this equation. So look now, we will start from here. So here is the second part. So we are starting from here. So this is equal to this now. Integrating both sides. So when we will integrate this side, so this will 1000 over 100 minus x. So I'll tell you the method. First you will shift 100 minus x whole square to the numerator. X differential is put there. So you will add 1 into the power and divide with the whole with the same number. So this answer will be there, and on the right hand side t plus c will be the answer, because in the beginning it was given that t is equal to 0 and x is equal to 0. So you are going to put these values into the equation. So t is equal to 0 and x is equal to 0. From here you will get the answer of the c. So this is the answer of c. Now again you will put this answer of c into the equation. So 1000 over 100 minus x is equal to 10 plus c. 10 plus t. Okay, and from here you will shuffle the values, you will cross multiply the values, so making x the subject. So this is the answer. So this is the thing which was required to be proved in the second part. So you can see here second part is done now. Third and fourth part are much easier, because the last step which we have obtained now, we will put x, we will find x when t is equal to 90. So we will put t 90 here. So third part will be done. Fourth part is also very easy. Find the value of the t when x is equal to 50. So you will put 50 in place of x. So from there you will find the value of t. And the last part is a technical part. So sketch the graph of the x against t and explain what happens to x when t becomes very large. Okay, so here is the Last part now. So here is the equation. So when t becomes very large, so this denominator factor will become to the 0. So 100 minus 0 will be equal to x is equal to 100. So this will be the answer. From here you can see x is equal to 100, and the graph will be like of this shape.